Hello, everybody. I'm very happy to show you my new book that was just published a couple of days ago. So this new book is about stress analysis for lightweight structures. So I spent more or less 6 years doing this book, and it is basically a combination of all my teaching materials blended with my research materials, especially my MATLAB routines for many different finite elements, and also for the modeling of aircraft structures, structural idealization, buckling, and composites. So I basically try to put everything together in this book, my teaching materials and my research materials and MATLAB code, which gave basically a book with a total of around 730 pages. So you can find this book in Amazon. You can find in Amazon US. So if you do Amazon.com and if you search for the title of this book, you can find it for sale there. You can also find this book in Amazon.co.uk for the UK market, and you also can find the book for Amazon Europe, where it's for sale in many different Amazon websites for different countries. Right, so this is the preface I wrote for the book, so I'm going to leave it here so you can pause the video if you are watching this, and if you are interested to read the preface to have a better idea of the contents of the book and why I decided to do this book as well. All right. Now, next I want to show you the table of contents and give you some overview of the main chapters on this book. So the first chapters are introductory chapters, are basic chapters where we have vectors and tensors, so where the basics about the manipulation of vectors and tensors and eigenvalues, eigenvectors are introduced. Then you have a second chapter on statics, which is also very basic concepts, equilibrium equations. Then you have an important chapter on basically stress analysis, where it is shown the definition of stresses, stress transformations, principal stresses, principal strains as well, equilibrium equations for stresses, plane stress analysis, where also introduces the Mohr circle, a very important concept. And then I go a little bit further, talking on some strain measures, some stress measures, talking about Hooke's law for elasticity, and also a very important thing is yielding, so I give some introduction of some yielding criteria. Right, following these basic chapters comes the bending and beam deflection, which is going to be very important for the formation of thin-walled structures. And then there is a big chapter on energy methods, so I try to detail this chapter with many examples. Not only this chapter, but all chapters have many examples with solutions included. But energy methods are very important for also for the chapter on numerical methods and for the derivation of some finite elements. So I think is very important to have this chapter very well detailed. Then chapter 7 for torsion, so where basically torsion is introduced for thin-walled structures and multicellular cross sections. And you also have then a chapter on the transverse shear for thin-walled cross sections. After this chapter 8 comes an important chapter, which is a chapter on aircraft structures, where basically it is introduced as some techniques for structural idealization, And this chapter is dedicated for the analysis of aircraft structures, because they need to be very lightweight structures, right? So basically, in this chapter, it is presented the construction of idealized structures. How can we simplify a real structure into a simplified model? And then do the analysis for the transverse shear flows, and also this section 9.3, energy methods and deflections, where basically we take the concepts from the work and energy methods from the previous chapter and apply this for the prediction of the deflections and twisting of aircraft structure, like a wing, for example. So this is also one important thing is that in this section 9.3 I provide a MATLAB code basically for the automatic calculation of deflections and shear flows or shear stresses and bending stresses as well in aircraft structures, for example, for wing, right? So I'm going to show you one example where you can see what this MATLAB code that is included in the book can do. All right. Then chapter 10 is all about numerical methods. So basically, the foundation of numerical methods, or the weighted residuals, are first introduced. The weak formulations, then and then some formulation of some typical finite elements, like for example the constant shear strain triangle, and also the 3D hexagonal element. I'm going to show you as well some examples simulated with these elements. Another important thing is that the MATLAB code as well is included in the book for the formulation of these elements, so that the interested reader can get these elements into their MATLAB and do the simulations and get some results. All right. After that follows the chapter on plates and shells, where a detailed derivation of the shell formulations are given, and then also application on plate elements, which is quite easy after having the shell elements. It's quite easy to get the plate formulation. And an important thing in this chapter is that I provide also a MATLAB code for this one for a fully integrated 4-node shell element, and also the MATLAB code for a 3D solid shell element. So this is included in the book as well, basically for the construction of the stiffness matrix of these two elements, which then the reader can again use in MATLAB. Right. Next follows a chapter on spar theory and pure diagonal tension fields, and also buckling of plates and shells. And this buckling of plates and shells comes with a MATLAB code for the prediction of the buckling modes and the critical buckling loads as well. I'm going to show you as well some figures in this video, where you can see some results obtained from the code included in the book. So this chapter is very important for design of spars in a wing, for example, an aircraft. The pure diagonal tension field, especially for thin shear webs, is very important for that effect. Okay, and then the book ends with a chapter on composite materials. This is only for the structural design of composite materials. There's nothing about manufacturing of composite materials. It is not the purpose of this book. But the good thing is that I included also here the MATLAB code to model composite materials with the shell elements developed in previous chapters. So I think is interesting. So that's the main idea of this book, is not just to present these important concepts for the modeling of lightweight structures, but also to give the MATLAB codes for many different structural elements, structural methods like the buckling, modeling composite materials, and modeling of idealized structures. That's the main idea of this book. It's the main contribution, I think. You can see that in appendix there are many appendixes with the full code for these different elements I just told you, all in MATLAB. Okay, I can give you now some very few images of some examples simulated with these MATLAB codes included in the book. For example, this example you see here and here was simulated with MATLAB code from this chapter 9 aircraft structures, especially these energy methods and deflections. So you can with this MATLAB code you can predict the shear flows, you can predict the deflections, as you can see here. Maybe I can zoom in. You can see the original configuration of the wing and then the deformed configuration on this side, right? All predicted with by using structural idealization. For example, the constant shear strain triangle. One example I'm showing here now is, for example, the modeling of a plate with a hole. So I'm showing only 1/4 of the plate. So you know that in the vicinity of the hole, the stress needs to be 3 times the stress applied on this region. So you can model these kind of problems with this constant shear strain triangle included in the book. For example, for the 3D hexagonal element, you can simulate this kind of things. For example, this is an hinge where you have two deformable bodies here, and you have a pin which is considered to be rigid. So basically, for this simulation, the MATLAB code for the stiffness matrix of this 3D element is included, and you can do this type of analysis. Another example is shell analysis. So the 4-node shell element included in the book, you can simulate this kind of thing. So what you see here is 1/4 of a sphere, or not 1/4, 1/8 of a sphere, where you have two loads, one applied in this direction at this point and the other applied in this direction. And then you can, so this is a typical benchmark for shell analysis. So this is something you can simulate with the shell element included in the code. As you can see, I'm not showing all of it, but you can see the MATLAB routines. They are included in the book in this form, so you can have an idea of the MATLAB code you can expect. Another example is a 3D solid shell element. So you can see you can see the thickness here, right? You can see this is a 3D solid shell element, and you can do this kind of simulations. So a pinched cylinder. This is the scaled deformed configuration you obtain from the MATLAB code included in the book as well. The last example I want to show you is for the buckling. As I said, there is a chapter on the buckling of plates and shells and the spars, diagonal tension fields, and this is the kind of results you can obtain from the MATLAB code included in the book. You have here 1/4 of the plate, which is under compression. I think it is fixed in this boundary and also fixed in this boundary. And then you have here and there you have symmetry boundary conditions, right? And what you see here are the buckling modes. The first, well, not the first. This is mode 3, mode 4, mode 5, and mode 6. But the result obtained from the MATLAB code for the critical load is 158, and if you compare with the reference result, which gives 157.91, so you can see it is quite accurate, the prediction of the buckling critical load. So this is also the kind of problems you can analyze, the buckling of plates and shells from the code included in the book. So that's it, basically. Really, this just going back to the first page. So this is the book I just got published. I'm really very happy to have this book out, because it's a work I've been doing for at least 6 years, compiling many examples with solutions and with MATLAB codes I have from my research activities. And so I decided to put everything in the form of this book, which you can find on Amazon, any Amazon website, and I think you will really like it. Right? Thank you very much.